Key properties of the sine x function on the interval from 0 to 360. These are the basic important pieces of information that you need. So for the sine function, the table is 0, 0, 91, 180, 0, 270, negative 1, 360, 0. So these are the 5 points that are graphed on there. You run the graph through the points and the sine curve looks like a sideways S. The amplitude of this sideways function is always the max minus the min divided by 2. That's going to give you 1. The period of the function lasts 360 degrees. The intercepts, it crosses the x-axis, are at the values of 0 degrees, 180 degrees, and 360 degrees. The domain of this function is x belongs to real. For the entire function is x belongs to real. If it was for one cycle, it would be the domain from beginning to end of one cycle. So for one cycle, the beginning and end would be that is circled right there. So this information here. If we're looking at the domain of the entire function, this would be the domain of the entire function. Max is 1, min is negative 1. The range is y belongs to real such that it goes from negative 1 is less than or equal to y, which is less than or equal to 1. It never changes, except when there's some transformations on it. The graph is increasing from those values that you see there. That means the values are increasing, going up. So in a basic function, so the red graph, it would start here and these values are going up, so that's an increasing. We don't include the 90 because at 90 it's changing direction. So 90 we do not include. Going all the way to here, it starts here, not exactly at 270, but it begins very close to 270. The values start increasing again till we go to here. Again, we're only doing it for one cycle. So folks, that would be the red graph that you see there. And that's the value of where it's increasing. We include the 360 because if you notice, if we continue the graph will continue to increase after 360. The graph is decreasing from the period between 90 or along the domain from 90 to 270, meaning that at 90 it starts to change direction, so we don't include the 90. It continues to decrease till you get to 270. Again, we don't include the 270. Alright folks, this is everything here. Let's go on to the next part. So this is the key properties of f of x equals sine x on this following interval. Alright, if you're in 3U, this is what we would continue for the cosine function. So we now have the cosine function. The cosine function is as follows. Okay, we continue those values. Here there's the cosine function. And you should be able to fill in this chart pretty quickly with all the values. So again, like the sine, the cosine looks like a sideways C, so sine looks like a sideways S, cosine looks like a sideways C, and what we're doing is filling in the amplitude, the period, the intercepts, the domain, the max, min, the range, and when it's increasing and decreasing. Hopefully you got all these values. These are important to note and to understand, especially if you're moving on to the grade 12 level. Alright. So, 5.3, transformations of the sine and cosine function. You have the equation y equals sine x. These are the basic coordinates for the y equals sine x function. The y equals cosine, these are basic coordinates for the cosine. The tangent we're actually not going to do, but it's not a bad idea to see them. But I will not be asking you anything involving the tan function, and the reasoning is that it's enough for you to memorize the sine and cosine without adding something that has a little bit of difference. But I do want you to note that the tan function does look very similar to the cubic function with a bunch of asymptotes. So at the undefined parts, there is asymptotes, but it's not a crucial part. Don't worry about that. We'll use that in grade 12. All right, so if we have the equation y equals a sine k x minus d all plus c, the values of the function change. So if the basic value, the amplitude is always equal in the basic to 1. The amplitude in the transform function is equal to the absolute of a and whatever units is involved. The period is always 360 in the basic function. In the transform function, it is equal to 1 over k times 360, or 360 divided by k. So either or is acceptable, whichever one you're more comfortable with. Now, period, let's talk about that. If you have an example of let's say a function that looks like this, and you need to find the period. So what you have to do is make sure that the coefficient of x is 1. Once you find the coefficient of x is 1, you look at the k value, and so the amplitude is 2. That's easy to find, but let's look at the k value to find the period. The amplitude has nothing to do with the period, so we don't need that to be able to answer this question, but the period is 1 over k, which is 1 over 5, times 360. 1 over 5 times 360 is equal to 72 degrees. So the answer to this would have been 72 degrees. That's the period. All right, back to the original question where we had the amplitude, which is a, the absolute of a, the period, which is equal to 360 over k, or 1 over k times 360. The phase shift, PS for short, there is no phase shift for the basic, but a phase shift in a transform function will always equal plus or minus d. Plus or minus d is all relative to what's inside there. You are either right d or left d. Right if it's positive, left if it's if it's x minus d in brackets, it's right. If it's x plus d in brackets, it's left. So there would be a vertical shift. A vertical shift in a basic is obviously none, but in a transform graph, it will be plus or minus c. So up or down from c. Plus if it's up, down if it's minus. So negative if it's minus. If I ask you to graph 2 cycles and I ask you to state the domain would be x belongs to real such that x is between the values of the start of the cycle to the end of the cycle. If I use the words at least, and I ask you to graph and state the domain, at least means is that it continues on past the 2, whatever cycles I ask you to draw, it continues on past it, and because it continues on past it, it's just straight x belongs to real. Alright, did you know that the cosine x graph is a phase shift of the sine x graph? And this is true, because if you look at the cosine x graph, the cosine x graph is equivalent to the sine graph shifted to the left 90 degrees. If I took the sine x graph and I shifted left 90, it would begin, on the y-axis, it would begin like the cosine graph. Alright, so let's look at that function. We see that function that's traced out there, and we need to find the equation of that red graph. The cosine begins at the y-axis, so that means there was no phase shift. But the amplitude is different, so we need to find the value of the amplitude, which is 4. We also need to know the k value. The k is affected by the period. The period is equal to 1 over k times 360, which is equivalent to 360 over k, which is equal to the period of this particular red graph is 180 degrees. 180 degrees is equal to 360 over k. You can do the 180 over 1 and cross multiply, and you find out that k is equal to 2. So, what is our equation? Our equation is y equals 4 cos 2x. What about the sine equation? Well, the sine equation is going to be 4 sine 2 bracket, so the a value stays the same, the k value stays the same. The only difference is the phase shift. So we have to be able to trace a sine curve. So there is one sine curve traced. It is traced in green. You'll see that it begins to the left of the original cosine that we had. What is that value that it starts at? It shifted to the left 45 degrees. And there's another one. You could have used that value to find the black one. That one shifted to the right. How much? It shifted to the right, let's see. It shifted to the right of approximately 135 degrees. So it would be 135 degrees. But if you know how to do the green one, you're good to go. And the values that I'll give you are much easier to read. All right, let's look at the second one, part B. So you have to look at the sine graph and the cosine graph. So here's the cosine first. We can look at this function, or we can look at this function. Both the green and the blue are cosine functions. But let's go to the next video so we can continue this.